Hi, Assalamualaikum and good day. Today you are going to learn on how to find product of two vectors. This is the objective of today's lesson. Hopefully, by the end of this session, you are able to perform product of two vectors, namely scalar product and vector product, and able to explain the difference between these two products. A vector can be multiplied by another vector but may not be divided by another vector. There are two types of product of two vectors, namely scalar product and vector product. The scalar product, which is also known as dot product, is denoted by A dot B and it possesses a scalar quantity or a value. The vector product, which is also known as cross product, is denoted by A cross B and it possesses a vector quantity. The scalar product of two vectors can be defined as the product of the magnitude of the two vectors and the cosine of the angle between the two vectors. Consider two vectors A and B and let theta be the angle between these two vectors. The scalar product A dot B is defined as the magnitude of A multiplied with magnitude of B multiplied with cos theta. The scalar product can also be calculated by adding the product of the corresponding components of the two vectors. Consider two vectors A and B, in which vector A is equal to a1i plus a2j plus a3k and vector B equal to b1i plus b2j plus b3k. A dot B is defined as A1 times B1 plus A2 times B2 plus A3 times B3. Both methods work and the result must be equal to a value. The vector product of two vectors can be defined as the product of the magnitude of the two vectors, the sine of the angle between these two vectors, and the unit vector in the direction of the vector product. Consider two vectors A and B. Let theta be the angle between these two vectors and E be the unit vector in the direction of the vector product. The vector product A cross B is defined as magnitude of A multiplied with magnitude of B multiplied with sine theta multiplied with E. The vector product can also be calculated by using the determinant of order 3, with ijk in the first row, the component of the first vector in the second row, and the component of the second vector in the third row. Consider two vectors A and B, in which A is equal to a1i plus a2j plus a3k, and vector B is equal to b1i plus b2j plus b3k. By solving the determinant of A cross B, you should get a vector as the answer. We normally use this formula to find the vector product as compared to the first formula. Generally, following are the formulas to be used to find the scalar and vector product depending on the information given in the question. Bear in mind that the answer for scalar product is always a value and the answer for the vector product is always a vector. Take note that when A dot B equal to 0, the vectors A and B are said to be perpendicular or, in other words, orthogonal. This is because when the two vectors are orthogonal, the degree between these two vectors is 90 degrees. When you substitute into the formula, cos 90 degrees is equal to 0, which result A dot B equal to 0. On the other hand, when A cross B equal to 0, the vectors A and B are said to be parallel or, in other words, collinear. This is because when the two vectors are parallel, the degree between these two vectors is either 0 degree or 360 degree. Refer to example 2. You need to find the scalar product for vectors A and B when the magnitude of A is 4 units and magnitude of B is 5 units. By substituting theta equal to 45 degree into the formula of A dot B equal to magnitude A multiplied with magnitude B multiplied with cos theta and calculate, you will get 14.1421 as the answer. Substitute theta equal to 90 degree into the formula, you will obtain 0 as the answer, which concludes that A and B are perpendicular or orthogonal. Now refer to example 6. You need to find the scalar product of the two vectors u and v. To find the scalar product, you need to apply the second formula by multiplying the corresponding component of the two vectors and total up the answer 1 times 3 plus negative 2 times 0 plus 4 times 2 equal to 11. Next, refer to example 7. You need to find the cross product of vectors A and B. To find the answer, you need to use the second formula of the cross product, that is by using the determinant of order 3. Substitute ijk in the first row, the component of vector A in the second row, and the component of vector B in the third row. By solving this determinant as usual, you should get negative 36i minus 6j plus 8k as the answer. The scalar product may also be used to find the angle between two vectors A and B. From the formula of A dot B equal to magnitude A multiplied with magnitude B multiplied with cos theta, theta is equal to the arc cos of A dot B over magnitude A multiplied with magnitude B. Refer to example 8. You need to calculate the angle between the two vectors P and Q. Magnitude P is equal to the square root of 1 square plus 2 square plus negative 3 square, which is equal to square root 14. Magnitude Q is equal to the square root of 1 square plus negative 2 square plus 3 square, which is equal to square root 14. P dot Q equal to 1 times 1 plus 2 times negative 2 plus negative 3 times 3 equal to negative 12. Substitute the answers into the formula of theta and simplify. You should get 148.9973 degree as the answer for the theta. Now consider a three-dimensional space system with a point A. Let alpha be the angle between vector A and the x-axis, beta be the angle between vector A and the y-axis, and gamma be the angle between vector A and the z-axis. If vector A is equal to a1i plus a2j plus a3k, then the magnitude of A is equal to the square root of a1 square plus a2 square plus a3 square. Thus, the direction cosine of A are defined as cos alpha equal to a1 over the magnitude of A, cos beta is equal to a2 over the magnitude of A, and cos gamma is equal to a3 over the magnitude of A. By solving the direction cosine of vector A, you will obtain the direction angles of A, which are alpha equal to the arc cos of A1 over the magnitude, B equal to the arc cos over A2 over the magnitude, and gamma is equal to the arc cos of A3 over the magnitude. Refer to example 9. You need to find the direction cosine and the direction angles for the given vector A. The direction cosine of vector A are cos alpha equal to 4 over square root 29, cos beta equal to negative 2 over square root 29, and cos gamma equal to 3 over square root 29. By solving alpha, beta, and gamma, you should get the answer for the direction angles of vector A, which are alpha equal to 42.0295 degree, beta equal to 111.8020 degree, and gamma equal to 56.1445 degree. The vector projection of vector A onto vector B refers to a new vector in the direction of vector B. Meanwhile, the scalar projection of vector A onto vector B refers to the length of the vector projection. The scalar projection of vector A onto vector B is defined as A dot B over magnitude B. As for the vector projection of vector A onto vector B is defined as A dot B over magnitude B with the square, then multiply with vector B. Refer to example 10. Given two vectors P and Q, you need to find the angle between these two vectors, the scalar projection of P onto Q, and the direction cosine and direction angles of vector P. Magnitude P is equal to the square root of negative 3 square plus 2 square plus negative 1 square, which is equal to square root 14. Magnitude Q is equal to the square root of negative 1 square plus 1 square, which is equal to square root 2. P dot Q, which is equal to negative 3 times 0 plus 2 times negative 1 plus negative 1 times 1, which is equal to negative 3. Substitute the answer into the formula of theta, which is equal to the arc cos of P dot Q over magnitude P times magnitude Q, which is equal to 124.5376 degree. Substitute the answer as well into the formula of the scalar projection of P onto Q, which is equal to P dot Q over magnitude Q. You should get negative 3 over square root 2 as the answer. The direction cosine of P are cos alpha equal to negative 3 over square root 14, cos beta equal to 2 over square root 14, and cos gamma equal to negative 1 over square root 14. Solving alpha, beta, and gamma, you should get alpha equal to 143.3008 degree, beta equal to 57.6885 degree, and gamma equal to 105.5014 degree. The magnitude of the vector product A cross B is referred to the area of the parallelogram spanned by the two vectors A and B. The area of the parallelogram is defined by magnitude A multiplied with magnitude B multiplied with sine theta. As for the area of the triangle spanned by the same vectors A and B, The area is defined as half of the area of the parallelogram, which is equal to 1 over 2 of the magnitude of A cross B. Take note that the answer for the area must be a positive value and in unit square. In order to get better understanding on this lesson, please do the following exercise. In the next lesson, you are going to learn about product of three vectors.